All right, so this is the next video. This is video 3 of this unit. So this activity, identifying the ratio and the rate of exponential equations. Okay, we've already kind of looked at that with some tables. Let's get a little bit more into detail here about what those ratios are. Specifically, what if they're given to you as percentages? I guarantee you, you will run into a percent increase or decrease in your lifetime. In fact, you might already have done that. Okay. Especially when you get to be an adult and you start talking about interest rates. When you go buy a car, it's going to have an interest rate on it. Well, what does that interest rate mean? Well, it means that you may buy the car for $4,000 or $10,000, but if it has a 6% interest rate on it, you're going to be paying more than what you said you were paying for, right? So you will get a loan for 10 grand, but it has a 6% increase, which means that you owe 6% more every time the interest hits, usually once a month, right? So you actually end up owing more than what you thought the car was worth. So be careful with that, and so we need to understand how these work, right? So first thing we need to do is we need to know how to convert percents into decimals, and knowing how they work with fractions as well, but the most important part is converting these percents into decimals, okay? Now this is more so like a 7th grade concept, but it's been a while, probably for my 9th graders, that you've done this, so I want you guys to go ahead and try that. Convert these into a decimal. Pause the video. Try it. Go ahead. All right. So the way that you convert percents into decimals is pretty simple. You got 8% here, and if I want to convert this to a decimal, basically you just have to move the decimal over twice. But students get confused which way to move it. 8% right here means that the decimal is right here. Okay? The way that we convert it to a decimal is just move it twice to the left. Okay? And what do we put in the blank spot? Well, that's going to be a 0. So the way that we write 8% as a decimal is to write 0.08. And the reason why I move the decimal twice is because this. 8% is basically saying 8%, meaning 8 out of 100. Right? Now you might want to reduce this, or you can say, hey, if I want to move this down to 1, you move that down 2 spots, which means I have to do the same thing to the numerator and go blah, blah, and put a 0 right there, and this is where we get the 0.08. Moral of the story, move the decimal to the left twice to move a percent into a decimal. Okay? Let's try it on the other ones really quick. And again, if you didn't know how to do that and you didn't pause the video earlier to try it, now try for the rest of them. Okay? 23%. Well, 23% means that the decimal is right here. We need to move it to the left twice, so 1, 2, which gives us 0.23. For 115%, 115, the decimal's here at the end, move it over to the left twice, gives us 1.15 as a decimal. This one tricks a lot of students up. 0.07 here, 0.07%, which means I don't move it to the right. I don't all of a sudden move the decimal to the right. I still need to move that to the left twice. So 1, 2. So what am I going to do with these blank spots? Well, a 0 there and a 0 there. So I actually have 0.0007. Now some of you guys may put a 0 there. It's the same thing. No worry. Okay. So again, decimals get moved to the left to change a percent to a decimal. All right. Cool. And now if we want to go through, to answer this question down here in blue, if these were ratios, would they be increasing or decreasing? Well, let's take a look. This decimal is smaller than 1, so this is decreasing. I'm going to abbreviate here, decreasing. 0.23 is smaller than 1. This is also decreasing, right? 1.15 is bigger than 1, so this is increasing. And then 0.0007, that's definitely smaller than 1, that's decreasing. Let's move on. And you definitely want to pause the video and write this stuff down, because now we have to learn how to convert percents into ratios. Percents into ratios is a lot more to it than just changing it to a decimal. Okay, so that's actually what this is talking about right here, how to convert that to a ratio, whether it's growth or decay. Those are probably the 2 most important things on this slide, but go ahead and take a second, pause the video, more like a minute, just get a quick sketch of those graphs and get it all written down. All right, so this right here is from our first video. We see that f of x for exponential equations. We have f of x equals the initial amount times the rate to the power of x, with all that stuff up there for you again. This is specifically what we're going to get into. But basically, you're going to find your growth or your decay rate, if it's given to you as a percent. You're going to find that by doing either 1 plus or minus the percent as a decimal. If you have a calculator, generally it converts those percents to decimals for you. But we're just going to try it without the calculator, and I'll show you how it works with our TI calculators here in a second, our TI 73s. But let's move on to our first example, because you're probably looking at that like, what are you talking about? So determine the multiplier for each growth or decay rate. Well, this one says 12% growth, which means, I don't know, let's say it's my account. I have $100 in my account and it grows by 12%, right? So if it grows by 12%, that means 12% of 100 is 12. And so if it grows by 12%, I should have $112. The original $100 plus the 12 extra percent. So I should have more than 100%, right? So first thing we do is we take the decimal, the percent, and change it into a decimal. I see that it's 12%, and I just put that decimal right there, move to the left twice, blah, blah, and so I have 0.12. Well, hold on a second. If that's my ratio, that's less than 1, which means I'm no longer growing, I'm decaying, right? And so how do I get it to grow if it's 0.12? Well, this is not my ratio. This is just going to help you find my ratio. Here's what I'm talking about. So we know how to convert that. So 12% is the same thing as 0.12. I want you to think about that, what I just said. If my account is growing by 12%, that means I take the original 100% of what I have, right? And now I have to add an additional 12% because I am growing, and that's where this plus comes from. Because I'm growing, I'm going to add the 12% to it, okay? Well, what is 100% plus 12%? Well, that would mean that I have now 112% in my account, or whatever it may be. Well, we can't use percents as rates. We need to change this to a decimal. So how do we do that? We drop the percent, and we change it to a decimal by moving it over twice, right? That gives us 1.12 as my ratio, and that would be an increasing ratio. Another way to look at it is if you just convert both of these to a decimal right now, 100 would turn into 1, and just like we talked about, 12% would turn into 0.12, and that still gives us 1.12, right? So we still have the same ratio. So our ratio is 1.12. If actually you have a calculator, and because we're growing, we're adding, right? If you did 1 plus 12, and then you clicked on the percent button, which is right in front of me, and I'm just not seeing it, right? Percent. That's right there, right above the 7 here with the TI 73s. So you do 1 plus 12%, it will automatically calculate the percent to a decimal for you. And it says 1.12, okay? So that's my ratio, and this would be increasing, and it should be because it is growth, okay? What about 53% growth? Give it a shot. All right, so 53% growth, because it's growing, it means I have to start with my original 100% of whatever I have. Growing means I'm adding to it, and now I have to add another 53% to that, right? That would give me 153%, but we never, ever use ratios as percents, right? We just need to convert this over to a decimal. So 153% turns into 1.53. So my ratio here will be 1.53. Don't want to do that? Use a calculator, okay? 100, if you do 100% plus 53%, 1.53, automatically done for you in your calculator. Or you can do it all in your head. Okay, perfectly fine. Let's talk about decay for a second. All right, let's try 9% decay. Basically what that means is I like to talk about money in accounts, so if I start off with 100% in my account, that's everything I have in my account right now, okay? And it's going to decay by 9%. Am I going to gain money or lose it? I'm going to lose it. And we show losing something with subtraction, okay? So we're losing something, we are losing 9% of that, and that's going to leave me with 100% minus 9% is going to leave me with 91% left in my account. Well, what is that as a ratio? That means convert it to a decimal, okay? So convert it to a decimal, 1, 2. That leaves us with 0.91 is my ratio. And that actually makes sense because decay means decreasing, right? And if it's decreasing, that means that my common ratio or my rate should be less than 1. In this case, we are less than 1. It's at 0.91. So that kind of makes sense here, doesn't it? Right? So remember, in this case, we're decaying. The big change here is because we're decaying, we are subtracting. And this is the same thing as saying, right, we could convert this over to a decimal and say 1 minus, and move this over 2 decimals, 0.09, which does give us 0.91 still, right? You can do it in your calculator even if you want to. You could say 100% minus 9% gives us 0.91, or you could have said 1 minus 0.09, and that still gives us 0.91. Either way, our ratio ends up as being 0.91 in decay. So pause the video and try this one out. All right, so this is another decay problem, right? So we're starting off with 100% of what we have, but we're decaying. So we're going to add to it or take away. We're going to take away because we're decaying, and we're taking away 15% here, right? Well, what is that then? Well, 100% minus 15% would be 85%. But that's not a common ratio. Common ratios aren't written with percents. We just convert this to a decimal, and we're good to go, 0.85. Right, so there's my ratio. Again, one more time the other way around, just like we did with our notes, is 100% written as a decimal is just 1 minus, and then 15% written as decimal is 0.15. And if we take that now and we do 1 minus 0.15, we get 0.85. Same ratio, just a different way of getting it, right? So our ratio is 0.85. Because that is less than 1, we are decaying, which just confirms this right here. Okay. Try again. Pause the video. Another decay problem here, 58% decay. So we are going to start off with 100% of what we have, and we are going to take away 58% of that. And because we're taking away 58%, we're subtracting here because of the decay. 100 minus 58. If you don't know what that is, just jump on over to your calculator. And if you accidentally forget your percentages, though, that's what kind of happens here when I see people do this. 100 minus 58 gives us 42. But not 42 as a ratio. Remember, that's 42%. So if you're doing your calculator, I highly recommend that you just hit percent minus 58%. Don't forget the percent button. And that gives us 0.42. Now, this is 42%, but the ratio should be written as a decimal, not a percent. So we just convert that over by moving it over twice. We get 0.42. Or you could have just done 1 minus and then 0.58. Just the decimal minus the decimal version of this, and that still gives you 0.42. Also decaying because it's less than 1. All right, let's see here. Quadruple. Okay, first things first. Not even let's try this one yet. First things first, quadruple is not a percentage. Okay? In percents, you convert to decimal. This is not a percent, though. So we want to write this as a decimal or a number, but we don't need to convert it by moving the decimal over twice because it's not a percentage. Quadruple, what does that mean, right? Well, if I have 1 of something, like bacteria, and it quadruples, right? Well, that means I'm going to have 4, right? And then if that quadruples, I'm going to have 16, or whatever you might want to think about, right? These are just as an example. Like a 1, 4, 16, that's going to quadruple. Again, what's happening here? What's going on? Well, we're multiplying by 4, right? Because we're multiplying by 4 each time, we are having a ratio that is 4. Okay, that's a ratio or a rate of 4. And quadrupling does make sense that we are increasing, hence the number bigger than 1. Okay, so now that's given. I want you guys to pause the video and try all 5 of these. All right, if you didn't, you either got stuck or you're being lazy. Do the work. All right, 95% decay. I see a percent and I see decay, which means I have to first convert everything to a decimal. And because it's a percentage, I know I have to take my original 100% of whatever it is I have, subtract off the 95%, and that's going to leave you with 5%, but then I know, Mr. Nelson, you have to convert that to a decimal because we can't leave it as a percentage. So hop twice to the left here, that's a 0.05, so my ratio is 0.05, and that would be decaying because it's less than 1. Doubled. Doubled is not a percentage, so I just have to think, well, what happens if I double something every time? I have 1, and then it doubles to 2, and it doubles to 4, then it doubles to 8, then it doubles to 16, then 32. What am I multiplying by each time? I'm multiplying by 2, so my common ratio is 2. Right here, 37% increase. Well, it's a percentage, so I know I have to do some conversions, and it's increasing. So I start off with 100% of whatever I have, but I'm gaining something. It's growing, it's increasing, so I have to add on the additional 37% that it will increase. And that gives me 137%, but that is not my ratio because I need to convert that to a decimal by moving the decimal to the left twice. Boom, boom. That gives me a ratio of 1.37. Okay? Next one, 4, quartered. Now, a lot of people want to say ratio is equal to 4. Not the case. Quartered means that it's getting cut down by a quarter, right? So we're quartering it every time. So if you had 4 and you quarter it, you're going to be left with 1, right? So you think about think about $1. How many quarters are in it? There's 4. So if I take 1/4 of $1, I have 1/4 of it, 1/4 of that dollar. So basically, yes, we could say divide by 4. But remember, ratios are never what you divide by. They're always what you multiply by. And that's going to be multiplying by 1/4. That means the ratio is 1/4. Or you could say 0.25. That works as well. 200% growth. I see a percent, which means I have to do some conversion. 100% is what I start with. Growing, it means I'm going to be increasing. That's going to be adding the additional 200%. Right? Well, 100% plus 200% is 300%. But percents are not our ratios, right? We have to convert this to that's right, a decimal. Move that decimal over twice. It gives us a ratio is 3. You might say 3.0, but that's the same thing as 3. Just leave it as 3 is fine here. So ratio is 3, and that is definitely increasing because that number is bigger than 1. Wow, that was a lot for a video. We're not quite done. We do have some videos coming up next, but you can work on those problems down below for some extra practice. Good luck with those.